Okay, so welcome. Going to talk you through how we can manage product development complexities in the travel and transportation industry, and rough agenda for the course of this session. Going to go through a basic introduction to engineering lifecycle management. Kind of go through engineering lifecycle management 101. As part of that, we're going to go through the navigation from a task to requirements that need updating. Look at the traceability that those requirements have and how that traceability runs throughout the entire life cycle. And we'll look at the kind of collaborative aspects of that, carry out some comments and a review. Next, I'm going to give you an overview of the configuration management capabilities that sit within the tool set. So this is the idea of being able to apply strategic reuse to our requirements and other bits of data throughout the life cycle. We'll have a brief section looking at how Watson IoT can be integrated into this picture as well, and how we can use that data in the context of our engineering lifecycle. And then once we've got all this data tied together, we'll look at how we can undertake activities which we can call learning to fish. So that's using the various JAS reporting capabilities to look at the data, put together some reports, and analyze them nice and quickly. At the end, we're going to have some success stories and some references, and we've got Mark Best here from IBM, who's going to give us a bit of insight into some of those as well. And we'll have time for a bit of Q&A right at the end. If you do have any questions that you'd like us to go through, you can also feel free to pop them into the chat in the meantime, and we can collate them there to come back later. Okay, so the engineering lifecycle management.
Sorry, Matt, we're actually not seeing your screen on this side. I don't know if others are, but I'm not.
Beg your pardon, I'm not actually sharing the screen here. Sorry, thank you for that. Okay. So can I check that that's now coming through?
Loud and clear, thank you.
Okay, great. Sorry, so I was talking through the agenda there. This was actually what I was referring to. So we'll go through each step here, but I've got some kind of outline of that as we go through the slides as well. Okay, so the engineering lifecycle management picture, previously when we've described this view, we've kind of shaped it in the systems engineering lifecycle V model. Now all pretense of this not being iterative has been completely removed, because now you can see we're kind of building up this picture of having a completely iterative set of functions and tools that fit together. So there's some slight differences here, and recently we just had the version 7 of all the tools that have come out. There's been some rebranding that's gone along with that, so I'll just talk you through what the different capabilities are. So on the requirements side, we've got the requirements management capabilities, which for the purposes of the JAS platform that we're looking at, comes in the flavor of Doors Next. For system design, we've got the thick client Rhapsody for handling models, and then the web-based engineering model manager, which allows us to consume those elements of the system design. Engineering test management handles all of the testing capabilities, and then all of our workflow management is now handled through a conveniently named engineering workflow management capability. So these names have changed in version 7. They are now much more descriptive of the function that they actually provide to the wider tool set. And you can see what this diagram is also indicating here is that all of this is kind of powered centrally by the idea that we can bring in Watson-powered AI to actually help us enhance what we're doing, particularly around managing the requirements and managing the other data sets within the life cycle, to help us work more efficiently. And then underpinning all of this, we've got some reporting tools. So there's the inbuilt report builder, which allows us to generate reports from within the tool using a GUI. And then we've got a series of tools which have now kind of been rebranded together into one family. So the family lifecycle optimization, and this now comes in 3 flavors. We've got Insights, which is the web-based UI for being able to drill down into live reports within the tools. Method Composer for handling frameworks, and then what was previously known as Publishing Engine has now just been shortened to Publishing. That allows us to put together more formal documentation on templates that we can actually use to produce documents on the appropriate formatted stuff. Okay, so I'm going to jump straight into looking at some of the tool, and I'm going to start out just by as I mentioned before, going into kind of some top level engineering lifecycle management 101, what are the kind of things that we would usually find ourselves doing in the course of actually going through some of our lifecycle data? So this view here provides us with a common kind of use case where we might jump in and have a look at some of our data. So this is looking at the impact analysis that stems from a particular defect that we've got. So the example project that we're looking at is this adaptive cruise control example. So it's an ADAS project, which is looking at semi-autonomous car functions. And you can see from that, we've got a particular defect that's been flagged up in testing. That then has a particular work item that's been affected. And that work item, in turn, is implementing a number of different stakeholder requirements. Stakeholder requirements then, in turn, link to the system requirements and have their design elements and their test information that's linked to that as well. So for any of these, I can kind of analyze the impact just by clicking on them and having a highlight of what the flow is and the knock-on of the impact is actually going to be here. So I can see what all of the various tests are actually going to be impacting further down the line. And for any of these, I can jump in and have a look at what the information is that we actually need to be able to look at. So if I go and look at the stakeholder requirements, for example, that then takes us into the requirements section here. So this is one particular requirement that we've got highlighted within this larger set of requirements. So this has now brought us into the requirements application. This has brought us into Doors Next. So if you've come from the Doors 9 world, things might look a little bit similar in as much as we've got a heading structure, which allows us to kind of organize the requirements into a hierarchy to make them more readable. We have unique identifiers against each of the requirements to allow them to be managed as their own separate entities. And we can kind of track the progress of changes to them as they go throughout the life cycle. But there are some key differences here with things that we've got in Doors Next instead. So for example, we've got diagrams which now actually appear. So this is a diagramming capability that's native to the Doors Next tool. So we can actually craft those within the tool. We've also got some slightly different view of the links and the way that they appear. So now we've got these little green ticks next to each of the links here. This is actually showing us link validity. So this is equivalent to what we had as suspect links before, and actually this has changed since version 6 of the Jazz tools as well. Previously, this was something that was only utilized in configuration management enabled projects. Now this is something which has been adopted throughout the entire tool set. So for any links that we have here, we can mark off whether those links are valid or whether they're suspect or whether they're invalid and they need addressing with more detail. We've also got the ability to introduce glossary terms here. So these are now terms which we can define across the entire project. We can utilize these and insert them within any of the artifacts that we have. And those will actually then, we can hover over those and we can get the definition of what that acronym actually means for us. So yes, so much like we would have in a Doors module, we've got the ability to look through these for particular words that we need to find, so we can jump through the content very easily and find what we need to within the module. We can also apply filters to be able to sort through all of the information. So one of the things that's very different in the world of Doors Next is the fact that we're actually dealing with artifact types. So artifact types allow us to control the behavior of the way that we utilize our requirements. They allow us to apply some rules to the way that we use these. So for example, if we look at the fact that we've got things like headings here, headings don't have any particular information against them, so we can't actually create any links against them because we don't actually want to be able to use those and work with those in the way that we would for the individual requirements. Once we've got all of our kind of filtering done throughout the different requirements here, we can also then set up views in the way that we would have done before, and those allow us to kind of slice and dice the data in different ways and get different bits of information about the requirements. Crucially now, because we're working in a web-based environment, whenever we see a hyperlink here, we can place our cursor over the link and we get what we call rich hover about the information from the artifact at the other end of the link. So this is now showing us a link to the system requirements, and you can see for this particular system requirement, without even actually navigating to that other module, I can see all sorts of information about what that artifact actually is. So I can see the various attributes that appear against it, and I can then in turn see what the knock-on effect of all the further links are from here. I can see where that's actually used in the module. So I get a lot of information without actually navigating to the other end of the link straight away. Within the context of what we're talking about with the AI power as well, we've also got a new function, which is the requirements quality analyzer. And in order to take advantage of that, what I can actually do is I can bring up a series of requirements which are in processes. So these are relatively new requirements which need to be looked at. So what I can do for that is I can select all of those requirements. I've got my RQA widget here, which doesn't seem to be loading. Let's try reloading that page. It's connecting to an external source. We may have had a bit of a connection drop. There we go. So what this widget actually allows me to do is it allows me to utilize the power of IBM Watson to analyze these requirements. And what I can do is I can click selected button, and those will actually come back with a score for each of these requirements. So now this is using a bunch of rules which have been taken from the INCOSE body for systems engineering, and those rules have been fed into Watson. Watson has been taught how to analyze and interpret those rules against actual live data. So we've got one here that's got a particularly low score of 40. So for each of these, we can actually expand the option, see what the reasons are that Watson has actually scored that as particularly low. And for each of those, I can actually expand that further and see what the guidance is around those particular details. So this ultimately is allowing us, we can have our engineers, rather than spending time going through a large number of requirements in painstaking detail, we can do a lot of kind of high level analysis, understand where the biggest errors are, and ultimately fix those errors as early as possible, reduce the rework associated with fixing those later down the line. And that ultimately allows us to keep our errors down, keep our projects on time and on budget, which is what we're ultimately looking to do. So once I've got my series of requirements and I've got them happy with the state in which we want to work with them, what we might actually then want to do is to go in and have a look at conduct a review within the tool. So for that review, I then have a particular role within that. I'm a participant. I come in and I simply want to be able to review these requirements which have been placed within here. So I can just open those up, have a look through, and for each of these, I can mark them off and move on to the next one and go through in turn. So that's keeping the kind of review process and all of the feedback as well. I can also kind of place comments against these as I go through them. It's keeping all of that kind of collaborative information, all of the process around the requirements within the tool. So we're making sure we aren't just having reviews captured, maybe outside of the tool or any kind of information, any sort of discussion that we want around any of that. We're actually keeping it all within the tool so that we can see all of the relevant information there. And you can see as I move through, I then get an update to what the status is against each of those. I can see that then my role within the review has been marked as complete, so I can say that I'm done with that. And then overall, there's a perspective of the review which tells me that my results have been captured, and I can see what the breakdown is of those. And then for each of the artifacts within the review, I can actually see what the status was that was recorded against it by each individual. So that kind of gives us, an overview of what we would do for working with a set of requirements. We could possibly, apply some further changes here, and the way that we would actually often manage those, certainly in the context of this project, is that we would work within what we call a change set. So to describe a little bit of what that is and what that looks like, I'm going to talk you through a couple of slides now just to introduce you to the concept of configuration management. So far we've been working in the adaptive cruise control basic stream, which just contains, it's just kind of the default set of information that we're working with. But what configuration management allows us to do is to work with different contexts of what this data looks like. So at some point, we're going to complete our review. We're going to arrive at a point where we're happy with what the state of those requirements look like. We'll take a baseline, which is a snapshot, which we can refer to later on in the project. We can also do with these advanced configuration management capabilities is we can actually spin off another stream from that basic stream. So we can take a premium stream, which is going to have some additional features to it that the basic stream doesn't have. And within that premium stream, we're then going to create this change set, which is going to be this update. So that change set is kind of a pseudo version of the requirements that one individual or set of individuals can work on. That can have an approval process around it, and we can monitor the differences between that change set and the live stream. Apply them. But once we're happy with what the state of those requirements and those updates look like, we can then deliver them into the premium stream, and that will then eventually lead us to a comparative baseline, which is going to be the premium baseline. And what the configuration management capabilities then allow us to do is to essentially run a comparison between those baselines, or indeed one of these baselines and one of the streams. Any of these different context configurations that we see here on this screen, we can run the comparison wizard between them, see clearly what the updates are. And essentially what this is allowing us to do is to manage all of the different versions very strategically, allow us to kind of reuse all of the requirements. So let's say there's a 70% commonality between what's in the basic stream and the premium stream. Our 30% here that's going to be different. It's just in the premium stream, and the configuration wizards here will allow us to manage and easily view all the differences between all these different states. What we ultimately get to with all of that is the idea of kind of having this product line engineering, as it's often called, which is the idea we can have these different streams of work, all of which are related to one another. So we have different versions and different variants, which we can branch off from one another. We can baseline accordingly. And really what this is ultimately about doing is to be able to strategically reuse all of that requirement information without taking a copy. So previously you would have had to have done the clone and own process. Now we can actually reuse the original artifacts themselves and kind of steadily control the delivery of those across different configurations. So let me go kind of further down into the weeds of the system design here, and I'm going to show you a little bit of what that looks like. Okay, so as I say, we've kind of gone further down into the weeds a little bit here. We're now looking at hardware requirements as opposed to stakeholder requirements, and you can see now that, as before, we've kind of got a different set of information here. So we've got a diagram which is showing us forward-facing radar. Now what we can actually do is jump to a different configuration of the same information. So we can jump to the premium model here, the premium stream that I was just talking about. And you can see that now this is actually the same module that we had before, but now we've got an additional section which is going to have the side-facing radar. And in fact, all of the IDs between the premium and the basic model are the same, because we are literally reusing the same artifacts. So what I can then do is I can do a comparison between these two. So we're currently in the premium stream. I'm going to compare the premium to the basic model, and after a few seconds, that's going to load up this comparison wizard. So there are a couple of different pages in this comparison wizard. The first of which is just telling us that there aren't any differences in the product properties between the two. The folder structure is the same here. What this will then show us is that we've got some differences in the actual artifacts themselves. So here we've got in our module here, if I go into the hardware requirements module, this is where you can see the differences between the two. So this is the premium model here, and this is the basic on the right. And you can see where there are differences between the two, and those are highlighted. So for each of those changes, I can open up the comparison wizard further, see what the differences are, and have them highlighted for me. And in fact, if I want to just scroll through the module, I can tick this box, scroll down through the content, and see a side-by-side comparison. And there we can see where the side-facing radar sits within the module content of the basic model. So it allows me to very quickly and easily see where the differences are and drill down further into those details if I so wish. And you can note from this page here, as I said before, that the IDs are actually the same between the two modules. So we can see we're actually directly reusing the content that's in the original source. Okay. So yeah, so this is the idea of being able to strategically reuse parts of our design. Next, we're kind of going to introduce the concept of what's an IoT and how that can be linked into the testing capabilities that we're going to look at in a second. So what's an IoT essentially allows us to take a number of different data sources. These can be in the context of something like a smart city or a smart hospital, anything where we're implementing a number of IoT devices which are feeding back frequent data to us, and that data will be fed into a cloud services and a platform, which will then have some kind of capability next to it, something like an operations center to allow us to analyze that data. And that data can also be analyzed using our analytics services, using the Watson IoT capabilities. So that can all be fed back into our continuous engineering lifecycle, and we can utilize that in our testing as well. And ultimately what that gives us is something like a dashboard that shows us a view where we've got all of this data fed back. And as you can see here, we've actually got some AI analytics going on here to give us some predictions about where we might have issues with particular components that we're actually out testing in the field here. So let me jump in and show you some of the testing data. So back in our subsystem hardware requirements now for the radar. So one of the things that we've actually got here on these views is a view that shows us the link to the test cases. I'm just going to switch back to my basic model here. Okay, not quite showing my links there for some reason. Okay, so what I actually wanted to show.
Matt, you need to be in the GC.
I thought I wasn't in the GC. No. Okay.
On the drop down, if you go where it says switch to GC at basic cruise control, at the top. That's it.
Okay. Yep. So we've got a number of links here in one of the views going out to the test cases, and what these test case links are showing us is again, we've got that link validity. So it's actually showing us that we've got that link validity going not just within the requirements, but actually we've got that being applied across the entire life cycle. And you can see here that one of the links that we've got here has got a suspect flag against it. We can also see here that these links are showing us different icons next to them. And one of them is actually showing us that we've had a recent failure in a particular test case that we tried to run. So much like with the links that we've got for the requirements, we can hover over the information on the link there, and we can see information about what's actually gone on with that test case, and we can see that we've got a failure on the most recent execution result that was run. So if I actually click on that link now and go to the test case itself, so what I might want to do first of all is look at the kind of higher level test plan and sort of see what's going on with all the testing information here. So this test plan is going to contain a number of different test cases, and the test plan is essentially allowing us to manage the work associated with testing a series of requirements. And those requirements are managed in what we call a requirement collection. So you can see here what the requirement collections are that we're managing as part of this test plan. One of the things that the test plan allows me to do is to reconcile the requirements. So that's checking that we have the appropriate test coverage for all the requirements that are linked to the test plan. And where we've got a new requirement that's been added to that collection, what we might actually want to do is to automatically generate a test case and assuming everything set up in the way that I want, then we'll be able to actually generate a test case automatically using the requirement information that was taken from the link. So going back to the test case that we were looking at before. We had the failure. I can see, looking down all the different sections here, that we have test scripts associated with this particular test case. So I can again hover over that, get the information about it, and I can see all the various results that have been run against that particular test case. I could jump into that and have a look at the steps that I want. What I really want to do here is, now that we've had a failure against this test case, is I want to rerun it and see whether or not we can actually pass this. So if I run this, what I actually do is it will then take me into a live run of all the steps associated with the test scripts that we've got connected to this. So for each of these steps, again, I can see with this is we've got an IoT device here that's feeding me information into the testing side of things. So for each of these steps, I can go through and I can record results here, and I can pass and fail them as I need to. Now, what I'm actually going to do here is I'm going to fail one of the steps, and with a failure, I can then actually create a defect that's going to be associated with this. So I'm going to create a new defect. I could also link to an existing defect if I so wanted. It records all the steps around where this actually failed, the information about the test case. It's even got some suggested information further down about what's actually needed to reproduce the defect. And again, once I've got all of this pre-populated, I need to choose where this is actually going to be filed. But once I've got all of that set up in the way that I want, I can click OK, and that will actually go ahead and create a brand new defect for me. So now we've actually got that registered. That then is going to be connected to this particular test case and this test plan, and eventually we can follow those links all the way back to the initial requirement if we so wanted. So this is kind of a run of how we're going through the creation of a defect. Ultimately, this is then referring to where we've got the test data. So if we have a look at what that IoT dashboard kind of looks like, so this is kind of giving us a view of, again, kind of sensors out in the field, this kind of operation manager perspective. For any of this, I could kind of drill down into the specifics and see what was going on with various forms of testing and so forth. But ultimately, that's feeding back into the testing and allowing us to execute the tests in the way that we need to. Right, just come like that. So let me go back to my presentation here. So yeah, so that's kind of how we can integrate IoT style testing data into the testing capabilities tests within the tool. So the last section just to cover here is this idea of kind of learning to fish. So once we've got all of our various data sources here, all these different applications, they're being fed into a couple of different data sources, one of which is what we call the lifecycle query engine. So this is providing us with a live perspective of what's going on across all of our various different projects, and it allows us to drill down into those using a couple of different sources. So the first of which is the report builder, which I mentioned before. So this is where we can actually build reports within the UI, and we can put those on our dashboard and utilize them in various different ways. The other thing that we can do is we can utilize this engineering insights tool, which part of which we've seen already with the dependency analysis. But what this ultimately gives us is the ability to build our own kind of live graphical views of different ways that we can explore the data. And you can see that one of the things it also allows us to do is to connect ultimately to IoT data and to be able to sort of drill down into the information there as well. So as I say, we've seen part of this already with the dependencies that we looked at before. Let's actually just go in and have a look at how we can learn to fish a little bit more within the tool. So in my, just make sure I've got back on my screen correctly. So back on the dashboard, this is kind of the overall hub that we work with. So all of our relevant reports are here. All of these reports, the various forms that we've got here are different widgets which we can move around and customize. And you can see we've got the information broken down into different tabs here across the dashboard. So there's a couple of different forms of reports that live on here. So one of which is this view that's taken, which actually gives us an overall sight of the figures that we've got for the satisfaction across the different types of requirements. So you can see this is kind of organized in a V-model shape. And for each of these, I can kind of drill down into what the actual requirements are, open them up, and have a look at what the requirements are within that group. Jump back to the dashboard a second. So we've got a kind of breakdown there of what the health state of all of our requirements is, and we can sort of see what the validation looks like on the testing side of things compared to those requirements. And you can see that there's kind of a match there between the sets of the requirements. We can also look at things like where we actually want to assess that requirement quality. So again, we're utilizing the power of the AI and the results that we're capturing against each of the requirements here. And you can see we've actually got a breakdown of what those look like, not just within the one project here that we're looking at, but also this is looking at a number of different project areas, and we can sort of see what the different scores are for all of these. And what we can ultimately do with a lot of these reports is we can build them ourselves within the report builders. So this particular satisfaction metrics report here, so this is one that's actually been constructed within the report builder. And you can see, again, this is kind of an interactive report here, but in a slightly different way. So any of these different results, I can drill down and I can see what the actual artifacts are that are captured within that subset. And then what we can actually do with these reports is we can utilize the results in a number of different ways. So we can actually export that to Excel, and we can actually link the spreadsheet to the live data that we're capturing from the data source for this particular set of results. So therefore, if we need to be able to share that report with somebody who isn't necessarily going to have an interest in accessing the tool itself on a regular basis, they can still see what the output of that report looks like. If we actually want to produce something that's going to give us more kind of formal documentation, we can actually export that to the publishing tool, and that will give us a template to start working with. And you can see we can export it in a number of different forms as well. Okay, so that concludes the demonstration part of what we're going to look at today. We're going to talk through some kind of live examples of how this is actually being used in the field. So in the case of synthesis, you can see here we've got a number of different companies that we work with in the travel and transport sector, and really what a lot of these companies are getting is the ability to manage their requirements and all of their engineering data in a more controlled manner. And really what this is about kind of understanding the status of the project at any given time, particularly around checking compliance, ensuring that we're meeting the legislative standards that are going to be applicable to the project, checking what the progress of the project is in the way that we've kind of just looked at, and also this is looking at implementing like the ISO 26262 standard that we can check against as well within the tool. So at this point, I'm going to bring in Mark, who's going to talk us through some of the IBM instances of what this looks like.
Okay. Hi. Yeah, thanks, Matt. That's a great demo. And you can sort of see from some of the intricacies of using the tool that there is actually a lot of functionality there. And so this is some of the customers from an IBM perspective that are sort of using some of those capabilities that you've seen. So we're going to pick out two really here just to talk a little bit more about them. The Metro Rail Tunnel project in Melbourne and the Crossrail project. So if we can, I think we've got some extra slides on those, Matt.
Yeah.
So the Melbourne Rail Tunnel is a huge project, a bit like HS2 in the UK, and a lot of tunnelling involved. A big project. This project actually was kicked off by the government first of all, and they actually used Doors Next to take the project on board, take the requirements for the project, and then they tendered against, tendered out for it, and then all the replies that came back from the tender were actually imported into the tool and compared. So using it a bit for tender management. When they then awarded the contract, I think that's the next slide, Matt. There were a number of partners involved, and so they all collaborate around the same tool set, with different projects, but essentially in the same toolkit, and that works really well from a collaboration point of view. So you get all the sort of tier ones, the tier twos, you know, the people that are sort of feeding into this project, built, you know, tunneling, the rail people, you know, people doing the electronics, whatever, are all sort of feeding into it. And I think that's a really good example of how collaboration can work within the tools. Next one, Matt. So Crossrail has been an interesting one. So this is a 15 billion project, so a huge project. And going right across London. I think the interesting thing for me is when you actually look at projects like this is actually the trains, when they're outside of the tunnels, travel at a certain speed, but when they enter the tunnels, they travel at higher speeds. You get sort of changes in the requirements, and it's little things like the approach speed to stations is doubled inside when it's in a tunnel, when it's acting as a metro train, and when it's outside of it. So you know, differences in requirements and how they flow down and how they're affected can all be looked at, you know, using impact analysis and things like that. Next one, Matt. So the Crossrail project, in the typical way that you would fashion requirements in the rail sector, are just structured in in different levels and with the traceability, like Matt showed you.
Okay, thank you, Mark. So, do we have any questions from anyone on anything that we've looked at today? Excellent. Do we have any someone who's not currently showing their screen? Can you tell me if we've got any questions in the chat or anything like that I need to address? Okay, well, in that case, then I guess in ideal systems engineering fashion, we can finish without with a minimal amount of rework and give you about 15-20 minutes back. So thank you very much for your time today. I appreciate there's a lot capturing your attention at the moment, but thank you very much. And if you've got any further questions, we'll be sending out some further information afterwards. Contact us, we'll let you know. Okay, thank you very much for your time today.